and I've got Visual Studio Code up and running already. So let's see if we can't think of a way of getting this done. Nope, and for those of you that haven't come across it before, Visual Studio Code isn't just for Python. There is doing the countdown timers that I use in here. With some JavaScript and HTML. And remember that all the times I say I forget which language I'm using. That's part of the reason why. Okay, let's do a new file. Which we will call lab, what is this, 5? Question 1.
Yeah.
Dot py. There's 2 for loops with the range for upper row and for the lower, and printed multiplying the row by the call. Okay. Okay, so let's think about what we have to do. So the lab says that. Someone remind me how to comment this out so it doesn't get run as code.
Hashtag.
Okay, so I'm just going to hash out these lines. So I'll leave that there just to remind us what we're trying to do, but make sure that that doesn't try and get run anywhere. So most of you have started off with for loops, which isn't a surprise, seeing as how week 5 was about for loops and while loops. And there was actually an example in the lab about doing multiplication tables. And it was something along the lines of for I in range 5 for j in range 4 print I times j. Okay, we all happy with that?
Yeah, I was thinking it's questions for like last lab 7. It was questions about lab 5. Yeah, sorry.
We can have questions about any lab you like. This was just the one I was asked first. So you can have a lab 7 one later. Okay, any problems with that code before we move on? Nope, you're all happy? Okay, let's run it. Syntax error, invalid syntax. What's the problem?
The colon after the 4. So after you declare the range, the colon goes at the end.
All right, hang on, I'm just trying to move this stuff about. I thought I'd set it so that the so you can see the code and the output. Yes, so it's pointing at range 5, and of course with the big red underline, so everybody should have shouted at me, "You forgot your colons, you numpty." Okay, so let's put in the colons and we'll try again. All right, so we've got something. Probably not what we wanted, so what we're going to have to do.
You have to like create space between each number, between each output.
Yeah, so yep, so we've done what we said we would. Although somebody remind me why the highest answer is 12. We were multiplying 5 before. Why is the highest answer 12?
Because the fingers by 5 would be it's the number before, so it'll be 4 and 3 instead of 5 and 4.
So remember, it's up to but not including the number that you've mentioned. So this actually goes from 0 to 4, which is actually 5 numbers: 0, 1, 2, 3, 4. So you get 5 numbers, but 0 counts. So let's not forget 0. Although in the output we probably do want to forget 0, because we don't really want to have all the multiplied by zeros. So remember that we can do other things. We don't have to always start from 0. We can say where we want to start. So we can start at 1, for example. And that's a bit better. So now get rid of all the zeros. Now we just want something slightly nicer. And Marissa put an example of how we might want to lay it out. So we'd still want the I times j, but we're going to add in some formatting. What's a \t mean?
Adds a space.
No.
Insert the tab.
Anybody? \t? For tab.
To
That's
insert
putting in a
what?
tab. In other words, it's going to push it over in the output a wee bit, in the same way as me pressing tab in the editor here takes us over a certain number of spaces. In this particular case, it's 4. What we're doing is we're adding in a tab in order to allow the stuff to be spaced out. So let's think about what's happening here. In fact, let's not think about it. Let's actually show it. Remember, one of the things we can do is run, but we can actually start debugging. So if you haven't come across it, you can start debugging. What I'm going to do is I'm going to set what's called a breakpoint here. In other words, it's going to get to this point in the code, and then it's going to pause for me to work through the code. Okay, so you'll see it started, it's running, it's compiling it, and it's got to here. And you can see I've set that breakpoint and it's got that yellow like a small cursor thing pointing to which line we're on. So we're in the first one, we're in the for I in range 1 to 5. Now, don't use I, don't use J. I and J are kind of hangovers from the old days. They're quite common to use as loop counters, but if you're doing a real program, actually say what it is you're counting. So we've got to here, and you can see we've got a new bar up here that gives us some options. We can play, continue. We can step over. So if you call a function, it means you don't have to go into the function. Or you can do what we are going to do. We're going to step into, in other words, we're going to go to the next line. So the next line takes us to the for j, and we've still got nothing happening. Nothing's happening in the output. But I'm interested in what's happening in the program, and what we've got here is something called a watch bar. So I'm going to watch some variables, specifically variable I. Now think of what's happened here. We're now in line 14, so line 13's been executed, and it says for I in range 1 to 5, so it's set I to 1. I'm watching I probably want to watch J as well. Why is there a name error against J? J's in our program, I can see it there. Why is J not showing anything? I can sit here all day. Come on, make a guess. Why is J not showing anything? Nobody? Not a declared variable, says Marissa. And declared is an interesting word to use because it is declared. I can see it in the program. So we're almost there. It's not that it's not declared, it's that we've not we've not assigned a value. We've not used it yet. We've just got to the start of line 14. We haven't executed line 14. So remember, in Python, variables only start taking some space when you use them. So it's in our program, but the Python interpreter hasn't kept any space for it yet. So it says, no, I don't have a variable called J, but only because we haven't executed that line. So if we execute the line and you keep an eye on the watch box, we execute it, J becomes a thing because it's run this line and it's set it to the value 1. Part of the reason I point that out is it's important to understand the values of your variables. And if sometimes you forget to set them a value, you might just say, you print J, and J just does something, anything. We don't know what it is yet. Often Python will just trap that and it'll say, no, you've not used it yet. But you might want to say J was in, it was actually the error output. At the start of your program, you may want to say error becomes not defined, just so that you always know. Anyway, we've now got I and J at 1. We've now got to our print command, which says print I times J. Well, that's easy. 1 times 1 is 1. Then print a tab. And then this mysterious end becomes double quote. So let's just run that line. Nothing happened. Why did nothing happen? No guesses? Anyone want to argue with me when I say that nothing's happened? Okay, let's think of what would normally happen when you go to print something. So I'm just going to stop this program. There's a stop in line 13, that's why we don't move forward. Well, no, that's where it stops, first of all, but then we can move forward. Let me just quickly make a new file. And remind ourselves what happens when we say print. We run that. Into our terminal, it says HELLO. Excellent. Is anything else happening? So, for example, if I go back to this editor and I press return, there's nothing on line 2, so did anything really happen? The answer is, of course it did. We've said, let's take another line. And one of the things that print does is it automatically says, oh, print hello, and then take a new line. We don't want it to do that to get this thing here. We want all of these numbers to appear on the same line before we go to the next line. And I'm assuming you all know that because you all went through the lecture, and if it's code that you didn't understand, you checked up on it, or asked about it, or researched it on Google. He hinted, not so subtly. So what we've done here is we've altered the print statement, and we've said, instead of taking a new line when we print, we've put quote, quote. So what does quote, quote mean? Anyone know? What is it? What's between the quotes? And it's not a trick question. Space? Well, no, because that's a space. What's between the quotes? Nikita says it's for the new line, but it didn't take a new line. It just stopped. So what is between the quotes? Honestly, not a trick question. There is nothing between the quotes. So what this says is, at the end, when you print, at the end of the line, don't do anything. Specifically in our case, don't take a new line. We want to print all these things on the same line, so don't take a new line. So let's see what happens again. Nikita, you're right, there is a stop in line 13, so that's to get us to the start of this so that we can run through it. Remember our watch over here, I and J, both have name errors because we haven't done anything with them yet. We set I to 1, we set J to 1, we print I times J with a tab and then nothing at the end. There's our 1. We take our next line, so we haven't executed this. Watch what happens when we execute it. It was 1, it's now 2. We print I times J, and look what's happened. So first time we printed I times J, we got the 1. What we couldn't see was there was also a tab. And in this particular editor, tab says move on to the 8th character. So it goes 1, or it goes 1, 9, 17. In other words, there's 8 characters between tabs. We keep moving. J goes from 2 to 3. We print 3. Keep going. J is 3, and let's look at what happens now. Remember this from J in range 1 to 4. Up to, but not including 4. So when we run this line, it says, oh, J is 3. It can't be 4. So let's jump over this line. Let's not do anything with this and go to the next one. So what do you think this 1 is there for? What's line 16 there for? Not to end the loop. The loop's finished. It's come out of the J loop at least. We're still in the I loop, but it's come out of the J loop. What's this print doing for us? And remember that print's for our output. So what's it doing for us? New line, says Nikita. What we're doing is we've said, okay, we've done the 1s for the I loop and the 1 through 3 for the J loop in the first line. So we want to move to the next line now to do the next one in the I range. So we step into it, it does the print, nothing appears to have happened, but if we had a cursor there, you would see that the next thing that we print is going to be down here underneath the 1. So we keep going. I goes from 1 to 2, and then we go through the same J loop again. J is 1, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. J is up to 3, up to but not including 4, therefore we jump out of the J loop and we finish that line as well. Again, we can't see it, but it means that the cursor's on the new line. And we can work our way through. I goes from 2 to 3. We loop through the J range, printing off all the 3 multipliers, and then finish off the line. I goes to 4. We print off all the 4 multipliers and take our new line. Back to for I in range 1 to 5. I is 4, so it's up to, but not including 5. So it jumps out. It finishes the for loop and says we're done. And it exits out of the program. Is everyone happy with that before we move on? Anybody get any questions about any of that code before we move on? And I wasn't kidding. This stuff was in the lecture. So if there's code in the lecture that you don't understand, look it up. Go check on Google. And if that doesn't help, ask us. That's what we're here for. So before we move on, is everyone happy with that?
I'm not sure if it is the same question as the one we were asked.
You
in the
speak up a
lab.
wee bit, Howie, you're very quiet.
Is it the same question we are asked in lab 5, question 1?
Well,
It says
what I'm doing is I'm
comprehensive.
getting to lab 5, but I wanted to make sure that you were all happy with the basics first.
Oh, okay.
And given that there weren't many answers to the questions, I'm guessing that you weren't happy with the basics first. So that's why I went through all of this to begin with. Okay, but we are going to get to this one. Don't worry, I hadn't forgotten.
Okay.
Okay, so we can do whatever we want in this. That's 1 to 5. We could go 1 to 8. I'll just take off the breakpoint and just run this. Okay, so instead of having 1, 2, 3, 4, we've got 1 to 8. If we wanted not the 3 times, we'd go up to 4. Take another column. Okay, so we can extend this any way we want. Now, part of the reason I'm saying you should have a check at Google is you can find interesting stuff. So if you'd looked up the for loop on Google, for example, you might have found a link like this that I'm putting into the chat. So it's just a tutorial on for loops, just for loops. And one of the things it says about for loops is, yes, you can have a range, so up to 9, or you can put a start value, and you can put what's called a step. So by default, we go up by 1. There's nothing to stop us going up in 2s. So we've gone 1, 2, 3, 4, 5, 6, 7, 8. If we put in a step here, we can go up in 2s. So instead of going 1, 2, 3, 4, 5, 6, 7, 8, we've gone 1, 3, 5, 7. Because it's gone up in 2s. If we go up in 3s, load down 1, 4, 7. So that should give us a 2. And we want to go up to 16, up to and including 16, which means we need 17. Two, 4, 6, 8, 10, 12, 14, 16. Okay, anyone get any problems with that just now? Everyone happy with that? Or does anyone want to suggest how it might be better? Or does anyone want to suggest how it doesn't actually answer the question? Come on, it's not a trick question. Look at the output over here. Look at what we wanted. What's wrong with this picture? I mean, there's a few things wrong, but what's the main one for the change that we just made between what's been output and what's here? Nobody? Well, yes, thank you, Nikita. The question asked for 2468 along the horizontal, and our output has got, they have got them going vertical. Yep, Lily, we'll come to, well, I'll finish this question, then I'll ask for more, don't worry, we will get there. So what that tells us is our I range is for up and down, and J is for across. So let's change our J range instead to 17.2. And we'll just go back to something smaller for this, just to make sure it works. And we'll run that. Okay, so that doesn't look right, but only because my screen's so small. Okay. Any other problems we've got just now? Still not quite right. We've lost the 2 for some reason. Or have we? Well, we haven't, because the question says multiply 2 by the 11, the 7, and 3. And ours is saying multiply 2 by 2. So our first answer is 4. So we're actually okay. So we need to be careful with what we're looking at and make sure we know what the answer should be. So 2 times 11 here, our first answer should be 22. So we're getting there. We've got this bit, the 2, 4, 6, 8, 10, and so on. Now we just need this bit, which is the 11, 7, 3. Ah, 11, 7, 3. So 11 minus 4 is 7, minus 4 is 3. So it sounds to me like if we start at 11, and go down to 1, oops, 11 and go down to 1, but instead of going up in 2s, we go down in 4s. That should say 11 minus 4 is 7, minus 4 is 3, minus 4, and then we go out of the loop. So we've got 2 times 11 is 22, 4 times 11 is 44, 6 times 11 is 66, and so on. 7 times 2 is 14, 7 times 4 is 28, and so on. 3 times 2 is 6, 3 times 4 is 12. So we're getting there. We've got our multiplication table. Any problems left? Or are you happy to leave it there? You're all happy to leave it there? Well, personally, I think I would try and sort out the layout. But hey, that's just me, I'm a perfectionist. Although I think you guys should be perfectionists too. So in the same way as I showed you how to start thinking about looking up what's available in Python, and all we ended up with was 2 for loops, which were in the lecture, and that's given us our table. The other thing we did, of course, was layout. So I want you to look up the options that you get in print, and if I hover over print, you can see there's lots of them. So start thinking about how you might get this layout a wee bit better. Are you okay with that? Because it was your question.
Yeah.
Okay. Any other questions then? I know there are. So it's just
Is it only the layout, or because the first line has to multiply the rest of the 11, 7, and 3 by all the numbers until 16?
So 7 times 2 is 14, 7 times 4 is 28, 7 times 6 is 42, 7 8s 56, and so on.
Okay.
3 times 2 is 6, 3 times 4 is 12, 3 times 6 is 18, and so on.
So it's just a layout now. Okay.
Yep.
Yep.
And Nikita's asked about the layout, and that's what I'm saying. I'm not going to do that just now. I'm going to leave that to you. Do it in the same way that we approached this one. We had for loops. We looked to see if there was more stuff available in the for loops. We had print. We've given you a pointer using the tabs and using the end and so on. So I want you to go and look at the print statement and see what other things you can get in order to get the layout the way you want it. But I'll leave that to you to do. Okay. Any other questions? Nobody's got any more questions? Lily, I thought you had a question. Nope. Nobody got any more questions?
I have a question about last presentation.
Mm-hmm.
1 sec. Just need a sec to open.
It's fine. Which one are you opening? And I'll open it too, just so I can read along with you.
Lab 7 presentation.
The week 7 menus.
Yes, yes.
Okay.
Slide number 19. I'm not sure.
I'm doing it on my screen. I should really be doing it on the screen that you guys can see as well, shouldn't I? So go on. I've got it on my screen. I'll just bring it up here so everybody can see it as well.
Okay. So I'm not. I couldn't totally get the not operator, I mean, if not number less than 7, this express should we always use brackets if we want to use like not we
Okay,
we
I think I
can't
get.
write
I think I get the
ju-
gist, Mikhail, and you can tell me if I've missed anything. So I'll
Mhm.
answer it, but I'll just bring it up first.
Okay.
Now, can I check something before I do answer it? You're currently doing computer systems with Henry.
Yes.
Have you got to logical operators with Henry? And or XOR?
Yes. Yes.
So you've got to not. You've done not as part of logic.
Yeah.
So the not operator is a logical operator. And I'm just bringing it up on the screen so everybody can see the code before I start putting something in. So here's the one that Michaela is talking about. And it's saying, get a number. If it's not less than 7, print something, otherwise print something else. So first thing, let me very quickly make a new file. In fact, let me just use this dummy file that I had. Very quickly is, of course, a relative term with my computer. Right, okay, so first thing we are doing is getting a number. What the computer's doing. So get a number, number becomes, and we'll make it an integer number, get some input, and I'm only doing it like that just for speed, okay? Of course, you wouldn't put what on an input, I'm just speed. And instead of doing if else that's on the slide, I'm going to do something else. I'm going to print come on, computer. There we go. Print okay, remember we did this way back in like week 1 or 2. Everyone happy with that code?
But does the class return the like int? It will print int, or I'm talking about type function.
Oh, thank you for that. Big red underlines, of course there's a problem with it. We don't want class, we want type. Oops. And rather than saying num less than 7, let's get the type of num first of all. So very quickly in the chat, what is the type of num?
Int.
Int. Any other guesses? And we want to back them up.
Don't we need a parenthesis after input?
Don't we need a what, sorry?
Parenthesis or bracket? I don't know.
Parentheses or brackets would be absolutely lovely.
Yeah, after input.
And again, we've got a red thing there that should have reminded us of that.
Yeah, space.
So let's put in your brackets.
Yeah.
So are we happy now? Oh, and by the way, you should take note of the colours here of VS Code. Look what it's done with the brackets for us. It's put them in different colours so we can see where the brackets are and which ones match up with which. Right, we're happy with the code now.
The white space after int is, I think, unnecessary.
Yes, but that's more of a stylistic thing.
Okay.
So I like it there. I think it makes the code clearer. I know that some people don't. Python won't care either way. I just think that makes it easier to see. But, so the code will run. I know that Jerry writes his code differently to me. So we type in something and it says it's class int. And it just shows you how you can mentally make that block. And you was wondering which class it was. So I typed in class, but that doesn't work for the print. We need to ask for the type. Okay. Of course, I did that and typed in a number. What if I typed in, well, of course, that's going to die because we have set the type, the class, to be an integer. Okay, everyone happy with that so far? Okay. Let me, in that case, do something else. Remember what the presentation did? If not, num less than 7. So what happens if here we say less than 7? Anybody want to predict what type we would have now? And you should have a poll on your screen right now.
Yeah.
I missed that, Lilia, sorry.
Yeah, it's just you put a number, but you need to put number less than 7, and that's all. It's the same int type, so doesn't matter.
Still int. So 3 of you think int, 2 of you think boolean, and 20, about 20 of you can't be bothered answering. Come on, make a choice. It's on your screen. You don't just get to sit back in your bed and listen to me drone on. You've got to actually take part.
I actually disagree with Lilia on the integer.
Okay.
Since we have the number less than 7, we have the thing that checks it, and that's the thing we'll get, like the Boolean response for that, like true or false.
And that's what we're seeing in the poll as well. Roughly half of you think it's going to be an integer. Roughly half of you think it's going to be a Boolean.
I guess just error, but I'm not sure.
But actually, I think so. Our input is asking for the integer. So how can it execute the Boolean?
Okay.
Yeah, it
Okay,
will be
well,
just error or not error. It's just because we're not putting something about boolean stuff. So
let's run it and see what we get, will we? Doesn't help that I've just changed the code by typing in the wrong box. Ooh, now it's a class Boolean. So why is that? What has changed it from an integer to a Boolean?
Can I tell?
Yeah, go for it.
We have the mathematical comparison with the number 7,
Mhm.
which by default makes it a bool type of number, type of data.
Yep.
I'm sorry, not number.
So within those purple brackets, what we've got isn't just the number anymore, it's a comparator. Is num less than 7?
so it means when we use an operation and print things, this means we using already like comparing things, boolean things, not
Yes,
numbers.
We're
should
doing a
be Boolean.
comparison. So we're saying we're comparing num with 7 and saying, is it less than 7? So the output for that isn't an integer, it's a Boolean. Is it true or is it false? And if we take away the type and just say num less than 7, if I type in 4, it says true. If I type in 9, it says false. What would it say if I type in 7?
False.
Because 7 less than 7, 7 is not less than 7, 7 is the same as 7. So 7 less than 7 is false. So what we've got is a Boolean now. When we did the num less than 7, the output for that is a Boolean. What would happen if we removed that bracket? Would that make a difference?
Yes.
Well, we know we've got an issue because there's a red underline. Let's run it, and it says syntax error. What that's saying is type can only take one input. So we need to make that thing one item. That's why we put the brackets around it. That then becomes one entity. And it's like what you did when you did arithmetic at school. Do you remember you had something, you might have had something like BODMAS when you were doing arithmetic, which said you do all your brackets, then you do your OVs, then multiply and division, and then add and subtract. And that's the order of things. It's kind of the same here. You do everything in the brackets first. So for this piece of code, we work out num less than 7 first, true or false. Then we work out type, true or false. And then we send the output of that to the print. That's what we're doing with all these brackets. And we're saying whatever's in the inside bracket, that's what we evaluate first. So remember where we started with this, which was get the input, and then we're going to say the output. So we have now got a Boolean output. So we can say if type num, I'll even pretend to not have the colons anymore. What do we put in here?
It has a type.
If we want, so see how when we did the print type and we got a true or a false, if we wanted to emulate that in code, what should we put here with in line 4? What should we print out? Oh, sorry, I didn't mean to leave the type in. We are going to emulate type within our code.
True.
True.
And so by a process of elimination, that'll be false. Or even place. Let's just have it as place, just for a change. So we check if the number's less than 7, and if it is, we print true. Otherwise, we print place.
Yeah, you can put whatever you want. Face, fish, whatever.
Did you speak up a wee bit, Lilia?
Yeah, I mean, we can write whatever we want. Like, it's like, okay, good, false, true, fails.
Indeed we can. So what we're doing is we're doing a comparator. That gives us a Boolean. But if we've got a Boolean, as you found out in computer systems, you can flip the value. So not true is false and not false is true. So if we put a not in here, we change the value. And we know that because when we run this and type in 4, it tells us it's true when, of course, it's complete rubbish. So it tells it's complete rubbish when, in fact, it's true. So what's happening here is we are saying enter a number less than 7. Then we're saying if it's not less than 7, print, did you really think that was less than 7? Otherwise, say, well done. So this one should be, no, it's not.
Why did we need to use brackets when we used if statement, but before we applied not?
Okay, so remember what I said about working out the stuff within the brackets first. If we don't have brackets, then we just work left to right. So if we take out the brackets, what we are saying is working left to right, we are saying not num. In other words, we have, in essence, brackets there. Because it would work that out first. We don't want it to work that out first.
So here we apply not for the whole statement num less than 7, and that's why we use brackets for them.
Yes. To make
And
it work out that first of all.
it is applicable for every situation when we want to use not only for one object but for several, and we put brackets.
Yeah, so look at line 9 there.
Mm-hmm.
We get 4 plus 2 times 3. What's the answer to 4 plus 2 times 3?
10.
Why?
Because firstly, we multiply, then we add.
Okay, how does Python know how to do that?
I
What
haven't
if
got
we
a clue.
don't want to do the multiply first? What if we want to do the addition first? What's the answer now?
18.
Okay, because we've done 4 plus 2, which is 6 times 3, rather than 4 plus the 2 times 3, which is 6, which would be 10. So we can change how Python decides to evaluate. So normally it would be left to right. If we don't want it left to right, we need to put in the brackets. So if we left out the brackets in line 3 for if not num less than 7, it would work out, first of all, not num. And given that number's an integer, that starts getting tricky. So instead we have num less than 7 to give us our Boolean, and then we apply the not to it. Does that make sense?
Yeah, thank you very much. I got it.
Okay. Anybody get any other questions?
Yes, I have.
Need to speak up a wee bit, Lilia, you're dead quiet.
Okay. So I have questions with lab 7. So they wrote here, create a fully commented version of the letters from the lecture. So it's absolutely the same what in presentation was before, like menu choose and just repeat here, or what is mean?
So hang on, let me just bring it up because I can't even remember what it is. So it's lab 7,
Yes,
question
1.
Okay, create a fully commented version of the ASMD from the lecture. Sorry. Okay. So rather than bringing up the lab question, what I'll do is I'll bring up the lecture.
Yeah, I just want to know it's the same, like just repeat from the lecture and put in program.
Yeah, all it's saying is, so you've seen how this works in the lecture by creating a menu and then creating a program to either add, subtract, multiply, or divide. So what it's saying is, do that, create that first of all, and in essence, it is just copying the one that's in the lecture. And then what it's saying is add on the other things. So modulus, floor division, exponentiation is question 2. So you can start with the base stuff from the lecture, and then you can add more stuff to it.
So add more stuff, it means something else?
More options, yes, more options in the menu. So your initial program allows you to add, subtract, multiply, or divide. And then once you've created that program, you can add in options for modulus, floor division, and exponentiation, because that's what question 2 is.
Okay.
And you will have to look up how to do those things in Python.
Yeah, just because it's like written full commented program, and I'm just like, what? Like,
Well, you can see the one in here isn't commented, he's just put in the code and just shown you it.
yeah.
So I'd quite like you to comment it so that you can get the, as you should do with any programming, as you certainly should do with the assessment. He wants you to comment it.
So we need to add comments in program, like explain every step.
I never like saying every step because, for example, here you've got, in essence, 4 things that are doing very similar things. So you could comment on the first one, but you probably wouldn't have to say the same sorts of things later on, other than possibly instead of just saying S, you could put a wee comment there that says hash subtract, just in case anybody's not sure about what S is. Particularly if English isn't your first language, it can be helpful to have why it's S.
Okay. Yeah, okay.
Okay. Anybody get any other questions just now?
About question number 3 in lab 7,
Mm-hmm.
should we do a program which basically shows a user one of the rules when he types the number of that rule, like the user
Yes.
typed number 6 and the program reads the rule number 6. Yeah.
Yep, exactly
Mhm.
that. So look up Zenith Python. You can grab that there, and if it's, you ask for a number, and if it says 3, it says you would print out simple is better than complex.
Mhm.
So you're looking for a number, it has to be within the limits. So I want you to put in the error checking as well. So if it asks for rule 99, it says 99 doesn't exist. But yeah, it is just as simple as that. Get a number, print out the right one.
Okay, thank you.
Any other questions? Okay, if there's nothing else just now, what I'm going to do is stop the recording.